Japan didn't just turn footsteps into electricity. They've officially cracked the code on making machines that feel, listen, and even gallop through mountains on hydrogen power, and you need to see it. At IREX 2025, the game shifted from building cold industrial workers to creating actual life partners. The Kawasaki Bex Kororo, the hydrogen-powered cyber horse. Starting with the robot that absolutely stole the spotlight. It wasn't a humanoid. It didn't have a face, and it didn't walk on two legs. Instead, it was a four-legged machine that looked like something straight out of a futuristic movie you'd see on your TV screen. This is Kororo, the cyber horse, and it is a fascinating blend of Kawasaki's heavy robotics expertise and its legendary motorcycle heritage. Think about where wheels fail. If you're trying to navigate a disaster zone, a rocky mountainside, or a patch of thick, muddy grass, a traditional vehicle is going to struggle. But legs? Legs can go anywhere. Kororo is designed so that a human can actually climb on top and ride it like a literal horse. You can gallop over terrain that would leave a Jeep high-centered. But here's what will blow your mind. Kororo is powered by a hydrogen engine, and Kawasaki is leaning hard into the green future, which means the only thing coming out of this robot's exhaust is pure water vapor. When you're riding it, you're looking at an integrated digital interface that shows you your fuel levels, stability metrics. And this is a great detail. It even projects light onto the ground at night to show you the optimal spots for the robot to place its feet. It's not just a vehicle, it's a living, breathing extension of the rider. This is Japan's way of saying that the future of mobility isn't just about autonomous cars. It's about robotic partners that can carry us through the world's most difficult environments. The robotic bear chair, emotional healing, and cuddle gadgets. Japan is currently facing a unique social challenge, an aging population and a work culture that leads to extreme levels of stress and loneliness. Because of this, IREX 2025 saw the rise of a trend that might look weird to an outsider, but is deeply practical in a Japanese context: emotional robotics. Imagine coming home after a 12-hour shift, exhausted and mentally drained. Instead of sitting in a standard recliner, you sit in a bear chair. This is a massive, soft, robotic bear that doesn't just provide a place to rest, it provides comfort. If you want to talk about your day, the bear will listen. It's programmed to offer simple, Zen-style advice, and most importantly, it will give you a hug. It sounds simple, but the physical sensation of a warm, robotic embrace combined with soothing words has a measurable effect on lowering heart rates and calming the mind. And the cuddle trend didn't stop there. One of the most humanizing moments of the exhibition was a display of robotic pillows developed by a graduate student who was in a long-distance relationship. These aren't just vibrating cushions. When you hug one pillow, the sensors transmit that exact physical pressure to a matching pillow held by your partner, wherever they are in the world. It's a way to use robotics to bridge the emotional gap that Zoom calls just can't touch. Japan is pioneering a future where machines aren't just productive, they are emotionally intelligent. Hyundai's Mobed, the universal mobile platform. While everyone else was trying to make robots look like people, Hyundai quietly showed up with something that might actually be more revolutionary. It's called Mobed, and at first glance, it looks like a high-tech flatbed on four wheels. It's small, only about 2 feet long and a foot tall, but don't let the size fool you. The magic of Mobed is in its suspension. Each of the four-wheel modules has 3 degrees of freedom, meaning they can move up, down, tilt, and adjust their angle independently. In action, it looks like the platform is literally floating. You can drive it over bricks, rubble, or even up a flight of stairs, and the top of the platform stays perfectly, eerily horizontal. The genius of Mobed is that it isn't a robot, it's a chassis. It's a smart foundation that can be turned into anything you need. You could put a box on it and make it an autonomous food delivery rover. You could put a high-end camera on it for a Hollywood film set and get a perfectly stabilized shot without a heavy crane. It could be a mobile lab in a hospital or even a robotic pet for a child. Hyundai sees these as the delivery vanes of a city, small rovers that go about their business alongside cars and pedestrians, handling the logistics of life so we don't have to. The tentacle mystery, Kobe Cosen's experimental tech. Every big exhibition needs a weird section, and this year, that title belonged to the Kobe City College of Technology. Their booth felt less like a corporate showroom and more like a mad scientist's garage, and that's exactly why it was so important. The standout was a Unitree G1 robot that had been modified with what can only be described as Dr. Octopus-style tentacles. The team was experimenting with transferring human hand movements into these multiple flexible limbs. Was it practical? Who knows? But beside it was a robot dog with suction cups on its feet, designed specifically to climb up glass and clean windows, with a brush attached to its head. A lot of people laugh at these kinds of prototypes, but in the Japanese robotics scene, this absurd thinking is the engine of innovation. They aren't afraid to build something that looks ridiculous today, because the underlying tech, like the suction foot stabilization or the tentacle dexterity, usually ends up becoming a breakthrough in a completely different field, like surgery or disaster recovery, 5 years down the line. But before we climb into a 1.5-foot steel giant that'll make your inner child scream, do me a favor, hit that subscribe button. We're covering the tech that's actually changing the planet, and you definitely want a seat for the ride. IREX, the giant piloted mecha dream. If you grew up watching Gundam or Transformers, the IREX booth was where you spent most of your time. This is a 1.5-foot tall, 1.4-ton monster of a robot that you actually climb inside to pilot. It's not an autonomous machine, it's an extension of the person sitting in the cockpit. Inside, the pilot is surrounded by 4 high-definition screens that provide a 360-degree view of the outside world. The control system is incredibly intuitive, with a teleoperation setup that allows the robot's massive arms and fingers to mimic the pilot's movements with almost zero lag. The CTO mentioned that their primary goal was simply to make it cool and make it move properly. While an 1.4-ton robot might seem like a toy for the ultra-rich, the tech behind it, specifically the lag-free transmission of human movement to massive hydraulic limbs, has huge implications for the future of heavy construction and space exploration. But for most people at IREX, it was just the realization of a childhood dream, finally being able to pilot a giant mecha, the railway giant, Z and the ZX3. On the complete opposite end of the spectrum from the bear chair was the Z. This was the most physically imposing robot at the exhibition, a heavy-duty infrastructure beast created specifically for the railway industry. Think about the work that goes into maintaining a train line. You have high-voltage wires, overgrown trees, and massive support structures that need constant painting and repair. Usually, this requires teams of people working at dangerous heights with heavy equipment. Z changes that. It's a massive, 2-armed power platform that sits on a base that can drive on both roads and rails. A human operator sits in a controlled cabin and moves the robot's arms using intuitive controls. The software is doing the hard work in the background, compensating for the massive weight of the structures the robot is holding and absorbing any vibrations. It can work at heights over 33 feet, pruning trees or handling heavy contact networks with ease. They also introduced a younger brother, the ZX3, which is more compact for working in tight tunnels or urban stations. This is the 3D philosophy in its purest form, taking a dangerous, high-altitude job and turning it into a safe, controlled procedure. Fourier intelligence, robots that can actually feel. The biggest technical hurdle in robotics isn't walking, it's feeling. If a robot picks up a strawberry, how does it know how much pressure to apply without crushing it? Fourier Intelligence addressed this head-on with their GR1 and GR2 humanoids. The GR1 is a marvel of tactile engineering. It is covered in nearly 2,000 tactile sensors that provide over 7,800 channels of sensitivity. It doesn't just touch an object, it senses pressure, texture, friction, and even temperature. It feels the world with the same nuance as a human hand. This level of sensitivity is what will eventually allow robots to move out of the factory and into the home, where they need to interact with fragile objects and, more importantly, with people. The GR2 took it a step further. It's faster, more agile, and capable of navigating stairs and uneven terrain at over 1 mile per hour. But its real superpower is its ability to determine its own height and adjust its movements in real time to maintain functionality. It's a massive leap toward creating a humanoid that can actually navigate a human world without being a clumsy, metallic hazard. Deep Touch, the Uncanny Valley Challenge. One of the more controversial entries was a company called Deep Touch, which specializes in what they call companion androids. These are robots designed to look as human as possible, and they are creeping right into the uncanny valley. These androids are equipped with neural networks that analyze your voice, your posture, and even your facial expressions in real time. If you look sad, the robot's eyes will change expression. If you tilt your head, the robot will mirror the movement to create the illusion of a deep, live conversation. They track your gaze and react with zero lag, aiming for full emotional trust. However, This booth also raised some of the most uncomfortable questions of the entire show. These robots are essentially giant sensors on two legs. Where is that data being stored? How is your voice and facial data being used? While the goal of providing companionship for the elderly is noble, the privacy implications of a neural network companion are something we're only just beginning to grapple with. The China challenge: quantity versus quality. While Japan dominated the specialized and emotional categories, there was an elephant in the room: China. It was impossible to ignore that the number of Chinese companies at IREX has exploded. While Japan is focusing on high-precision, specialized partners, China is playing a high-volume, aggressive game of mass production. Companies like Unitree and Lumos Robotics, which was only founded in 2024, showed off humanoids that can fall down and get back up in less than a second. These are being built at a scale that Japan is finding hard to match. One Chinese humanoid, the Agibot A2, recently set a Guinness World Record by walking 66 miles non-stop across Shanghai. China's philosophy is speed over perfection. Get the robots out there, make them affordable, and iterate fast. The final verdict: two competing futures. IREX 2025 revealed that we are at a crossroads. We have two competing visions for how robots will enter our lives. China is building the army. They want a humanoid in every warehouse and a robot on every street corner as quickly and cheaply as possible. It's about volume, speed, and aggressive funding. Japan, on the other hand, is building the partner. They are focusing on the emotional connection, the industrial precision, and the specialized integration between human and machine. They want robots that can fix a railway at 33 feet, carry you over a mountain on a hydrogen horse, or give you a hug when you're having a bad day. So, which philosophy wins? Let's be real, probably both. But what do you guys think? Let us know your thoughts in the comments below.